Okay, if you missed this one here, chances are you just didn't pause for long enough to think about what this really means. 6 to the 7th power means 6 multiplied by itself 7 times. And then we get to the next one. We're going to multiply all that junk here by 6 to the 4th, which looks like this. So when you write it all out and look at it, you'll very quickly see there is no 36 anywhere on this paper. So if you wrote 36 as your base, you forgot, several different rules. The first rule is the base never changes, just the coefficients do. And the second, of course, is that you're just simply adding the exponents. But if you're ever confused and you're not really totally sure, guys, just write it out and look. It's very clear once you do that that we have a base of 6 and we have 7 of them here, 8, 9, 10, 11. We have 6 to the 11th power. I think a lot of you are getting this sort of problem confused with, say, this sort of problem here. If we look at 7 and -3, these are coefficients. They do not have exponents next to them like the 6's did. So this is just plain old number 7 multiplied by n to the 4th, n to the 3rd. And this is plain old -3 multiplied by m squared and n. If these had exponents next to them, well then we couldn't obviously multiply them together. But they don't. These are just coefficients. They have nothing to do with these exponents. So we just multiply them. This is 7 times -3. There's an understood 1 right here, but that doesn't really change anything. So when we multiply, we get a -21. Okay? Then we can look at m to the 4th. I'm going to do these in different colors, and m to the 2nd. All right, well that would be m times m times m times m, so that's 4 of them, and another 2 of them, which makes 6 of them. So that's m to the 6th power. Remember, we're just adding those exponents. And then if you missed your n, chances are you might have forgotten that this one has a little understood 1 as its exponent. This is n times n times n times another n, so that's going to be n to the 4th power. So your answer should have been -21, m to the 6th, n to the 4th. Okay, for C, 8 to the 5th over 8 to the 6th, we learned that you just simply subtract these exponents. So we'll get an 8 to the 1st power, and it winds up wherever the bigger exponent is. In this case, 6 is bigger, so we're going to have 8 to the 1st power on the bottom, and whenever we need a placeholder on the top, we just put a 1. That, of course, is the same thing as 1/8. The other way you could have done it is you could have said, well, I have 8 times 8 times 8 times 8 times 8 on the top. I'll put my little dots here. And then I've got the same thing on the bottom, except I have it 6 times. And I'm writing it really fast, sorry. But you can just now cancel out the ones that match. So 8 and 8 would match, and those cancel out. 8 divided by 8 cancels out. These cancel out. These cancel out. These cancel out. What are we left with? We're left with an 8 on the bottom, and it's understood to be a 1 on the top. So either way you approach it, you should get 1/8 as your answer. For D, these numbers here are our coefficient. They have nothing to do with the exponents. So we're just going to treat this like the fraction that it is. -9/12 can be simplified. We can divide both the numerator and the denominator by 3. So -9 divided by 3 is -3 on the top, and 12 divided by 3 is 4 on the bottom. And then we look at our variables. We know that when we divide, we subtract the exponent. So we're going to get f to the 3rd power, and it's going to stay where the bigger exponent is. In this case, that's on the top. So we will get f to the 3rd on the top. Hope this helps.